So, hi everyone, I am Madhu. So, totally 11 years of experience I have in complete data engineering in IT field. So, today we're going to cover what is Snowflake, what is DBT, and what is the project flow. These things we're going to cover today. Yeah, okay. So this is complete end-to-end project training from source to target. Okay, from development and deployment and migration, we're going to do in the practically here. So first, why many companies are using Snowflake and clients? Why Snowflake here? Okay, so we have Redshift, BigQuery, and Teradata, and on-premises like sources and they were actually SQL Server. Then why Snowflake? So when it started, in 2012 it started, but for projects it is 2014. Okay, so still people are using the Snowflake. Why means here we have completely it built on cloud, completely built on cloud. So we have three cloud providers like AWS, Azure, okay, and GCP. Okay, these are three cloud provided to the Snowflake. Okay, so here AWS from 2014 and Azure from 2018 and GCP from 2019. So these are best one. So one more thing. So it is like a pay as use model. So one like example. Suppose you're going to somewhere. So you're going to book Rapido or Ola or Uber, right? So you're going to travel like 5 to 10 kilometers. Okay. Here one thing you are not hiring that captain driver and you are not buying that bike or scooty, just you are traveling 5 to 10 kilometers. So what you are traveling, for that you are going to pay, for that you are going to pay. So like that, so what you use we need to pay for that only. What we use here, like suppose we have taken 2 TB from Snowflake, so 1 TB is active and one more TB is inactive. So inactive. Okay. Then in this time we need to pay for only so 1 TB. So no need to pay for so one more TB. So this is like pay as use models. So what we use we need to pay for that only. Okay, this is one thing. And here we have separate layers. We have separate layers. Okay, Snowflake. If you go with the Snowflake architecture, so we have three layers: storage layer, compute layer, and cloud services layer. So the data going to store in the storage layer, but when you run the query going to run in the compute layer. So think the data is like 20 GB, okay, in the storage layer. So you are running one query that is like having like 10 pages of code you are running. Okay, SQL code, 10 pages of SQL code you are running in the compute layer. So now these 10 pages of code, it won't affect by this 20 TB of storage. So this is one advantage in the Snowflake. Okay, these 10 pages of code, it won't affect by this 20 TB of storage. So this is one advantage. Okay, or like we can call it like a decoupled structure. So decoupled structure and it won't, the query won't affect by the this 20 dB. And we have the clusters. Okay, clusters in the Snowflake, and it's like a to increase the power of the warehouse. So completely it's built on cloud, right? So everything managed by the Snowflake config, and it is a SaaS model. So no need to install anything like hardware, no need those things. Okay, come we can simply create an account. So wherever we go, just we need to have the URL and username and password, then we can start working with the Snowflake. So what kind of projects we have in the Snowflake? Completely like data migration projects, like here we have, so we have data in the source system like Oracle or SQL Server or some other CRM systems and hospital systems and bank systems. So we have the data. So those data may be going to receive like CSV files or JSON, Parquet, Avara, ORC files, XML files. So the ETL team, they're going to push data into S3 bucket or in AWS or Azure Blob Storage and GCP, GCS. So whenever the data is loaded into the S3, so from this point as a Snowflake developer, so our work will be start. So we need to integrate with the S3 and we need to load the data. So we need to handle the live data, sometimes live data and the bulk data and continuous data, S3 to Snowflake. There's a completed project structure is like Oracle to S3, then to Snowflake, again to DBT, data build tool, again to Snowflake, then again to Power BI or any reporting tools. So in between, what we are doing. Okay? So what concept we need to know? These are the completely workflow. You need to have the skills of Snowflake and DBT, and as well as SQL is a mandatory. So structure, query, language. You need to know out of 10 you need to know like you can rate yourself 8. This is the SQL is the matter. Okay, in this course I'm going to give the every SQL from basics to advanced like work level. This is completely in between. What are the layers we have in the Snowflake? Layers like raw layer, so it's like Yas copy of source data, so having the duplicate and null values and those data we have in the rack. Then we have staging layer. So here we have the complete deduplication. So without null values, proper data and proper column names, everything like a clean and neat data we're going to have here. And we have the curator layer. So in this curator layer, we have completely fact and dimension tables. It's uh, applied business logic. Okay, requirement total visits of doctor to the each patient on every day and total sales and what is the insurance policy discount sum, so like that. Okay, curator layer, here we go and have the fact and dim tables. It is like a star scheme. Okay, star schema.
Yeah, I have one small question, Madhu.
Yes, yes.
Do we can expect like any this data modeling part also here?
Yes,
Like
yes,
suppose
sure,
like if we want
everything.
to.
Yes, yes.
Okay.
So modeling concept like what is first thing like we need to know about OLTP OLAP systems, then normalization,
Mm,
denormalization, and then what are the conform dimension and conceptual dimensions. So everything end to end we're going to know from warehouse data lake data everything. Okay, so in final layer we're
okay,
going to
thank
apply the final layer we're going to apply the star scheme. Okay, so so this is a curator layer. So after that they will connect with the Power BI. They will. So when we are working in real time, so we're going to have the different names. Sometimes we have different layers. So raw layer, staging layer, maybe they used to call intermediate layer. Here final layer, presentation layer, okay, are reporting layer. So but these are standard names, raw layer, staging layer, curator layer. So as well as we know, right, DBT, it is a data build tool. So what is a part? So it is like completely ELT tool. Okay, usually we have ETL and ELT tools, right? So ETL is extract, transform and load, and ELT is like extract, and in like load and transfer. Okay. So here DBT is completely like ELT tool. Okay. So when we have data in the warehouse, okay, in the Snowflake warehouse or maybe a Redshift or Big or other, so then we need to connect the DBT. Then we need to do the transformation or like a framework. We need to do framework. You need to call framework. Okay. So why DBT? We can do the transformation within the Snowflake, right? We know Snowflake is very advanced. Okay, so we have worksheet, we have the database schemas, tables, and everything. So then still, why so many companies are using the this DBT means here I will give one small example. Okay, think so we have so three tables. So three tables in the Snowflake. One is A, and one is B like B, and one is like C. So here we have chain condition A to B and join condition B to C. So now my requirement is we need to join three tables A to B to C. So in Snowflake, what we do already we have the code, right, A to B and B to C. So we can't use same code. So tell we go and write again code. So it will take time and cost. So we need to write the entire code. But come to the DBT, here we have the A to B code. So we're going to give some name like B model, and B to C, we're going to be the E model. So directly without writing anything, so within a 10 seconds, we can join. So ABC tables, okay, like BTB. So this is advantage in the Snowflake. Okay, so this is advantage in the DBT completely. So not only like this, and we have the lineage graph and so documentation. What is like lineage means? Okay, so like so I have one model, so I don't know where it comes from. Okay, where it comes from. Okay, so I have some like ABC model or ABC table or ABC view, so maybe transcend table, so maybe anything. Okay, so I need to know where it comes from. So literally we're going to have real time, so hundreds of tables, and we're going to have 150 or hundreds of columns, and we're going to have the different database schemas, right? So but we need to know where it comes from. Okay, we need to check the data. Okay, and quantity we need to check. So for that, what we do, we going to define everything in the schema.yml file. Like, so the child is there where this child comes from. Okay, we go and check for the parent. Okay, after that we go and check for the grandparent, and after that we go and check for the great grandparent. So like the greatest grandparent, like that. So this child comes from, so greatest grandparent, greatest great parent, and grandparent, great parent, and child. So like that we're going to design everything. Models comes from where, which part. So this is one advantage in the DBT. So we can go into see, like it's a like graph, the lineage graph. So these thing we don't have in the Snowflake. And documentation. So if you want to do documentation in Snowflake, we need to copy the every script, and then we need to type, okay, the script. But here when we go with the documentation, simple command we can use like dbt docs. So it's going to create the entire project docs, like from models, okay, and snapshots, and SC type 2, and incremental, and macros, everything, hooks concept, everything is going to create. This is advantage in the this. Okay. So now come to the Snowflake. Okay, so like SaaS model, so pay as use model, and we have decoupled stretch, this thing. So still we need, right? There is not three things. There are many things. Okay, one is like zero copy cloning. Zero copy clone. So this is one good feature. So suppose we have database schema and table. So I give simple example. I have one table with so 1 TB data. So 1 TB data. Okay, see in the one database in the schema, I have 1 TB data. So many records I have. So this 1 TB data going to cost $23 per month. Okay, $20. But so I'm the Madhu, I'm the one user. There is another person, his name is like Mari. So you need to work on the same database, same schema, same tables, and uh, we need to maintain the data consistency. So when I'm receiving the data from source, I need to manage for the up to the end for the targeting. Okay, for the those business logic. So for that we need to back up the data. Okay, back up the data. So in real time we're going to have not only 1 TB, right? So we have maybe 20 TB, so depend on the project size. So here, so I'm going to clone this data. Clone is like copying the data. So copy the data, like suppose we're going to copy the videos and images in the mobile or laptop, right? Like that we're going to copy the data. So we're going to suppose I have the some like ABC database having this 1 TB. Okay. So $23. These are the storage and storage cost. Okay. Same data. I'm going to copy. Okay. Copy. So copy here. Same data. So I'm going to give the name is like ABC clone. Okay. So this data. So no storage here. No storage here, and no storage cost. But still, I have here like 10 billion records here in this 10 billion records. So same data I'm going to have the here say 10 billion records. 10 billion. But here the thing is like, so no storage and no storage cost here for this one. No storage and no storage cost. So this is one advantage. So why many companies going to choose Snowflake data warehouse. And here one more thing. So why we call like zero copy cloning. So copy is a data like copy like simply image and videos. And why zero means, so no storage. Okay, no storage. That's why it is to call zero copy cloning. And why cloning? Cloning is like, so we are not duplicating the data. Okay, so here this is original one, ABC database. So this is also original. This is not duplicate of this ABC database. So this is also original. Like, so without duplicating data, so we are copying the data. That's why we use it to call so zero copy cloning. This one function. And one more thing. So if any disaster happens, if any database or schema table drop, or any new employee, so new employee works on the data, so he updated wrong data, so without using where class, without using so where class, where class. So you have the wrong data. So we need to recover those data. So are we going to recover that data? Are we going to so recover that data? So this like one second. Okay. One second. Okay. So are we going to recover that data? So here we have time travel feature. Okay. So using time travel up to 90 days we can recover the data. If any table is dropped and if any disaster happen, if any wrong updation, so there are three methods or three ways using query ID, okay, and like timestamp, and we have okay, like offset. Using this method, we can recover the data. So using the this is the time travel feature. So we can access the historical data. So totally 90 days, and we have fail safe. Okay. So this is for 7 days. Okay. Okay. Totally, we can recover the data like 97 days. So this is one time travel is a so one good feature, and we don't have in other warehouses. This is good thing. So totally we can record it up to 90 days, and it will take some cost. This, and here we can handle every data like incremental data we can handle, and historical data we can handle. So here first we go with like what is incremental data. So first day today I'm going to receive so one data, so A and Ramu and his salary, and so second one you can see the okay, so salary this thing. Okay. Then third one Lakshman, so Lakshman and that is third. So these things we're going to receive. The first day I'm going to receive these three records. Okay, as example, we're going to receive so like millions of records or thousands of records or lakhs. Depends on the project. So we're going to receive. So what I'm going to do, I'm going to create one table like I'm going to create like table Ramayana. So I'm going to create table, and I'm going to load these data. So first day, okay, first day. So after loading creating table, I will load the data, and this is first day. So just first day, and second day, okay, second day I'm going to receive the data again, like this, okay, and here Hanuman, okay, then some salary, and like Ravana, okay, so someone, and some other person. Okay, two records we're going to receive. But again, with this data, we're going to receive this old data also. Second. So with the new data, and we're going to receive this old data and this second. Okay. And what we do, we're going to this table second day, we're going to recreate or like truncate and we need to load the data. So if you don't truncate and if you don't recreate, what's going to happen? So it's going to be duplicate data. If here just we have three records, but those may be like 3 million records in the real time. We need to truncate and we need to recreate the table and we need to load again. So without recreating a truncate, it's going to be duplicate data. So again third day. Okay, so you're going to receive some other data, 7 and 8, these records, and again 9. Okay, 4 records. Again, you're going to receive this last 2 days data. Yeah, okay, this is the day, third day. So this thing. Okay. So third. So again, what you do, but here, so Ramas, okay, these going to update. So Ramus, okay, these are going to update Ramas, okay, and again some new data. So again, what you're going to do? So not only update some, we going to delete. This going to delete from the data, and here Ramas updated and Lakshman deleted, and so remaining same and some new records. So again we do truncate and again recreate table or truncate or recreate the table. These things we going to this is one approach. So what is happening here? It's going to be uh, like it will take the time. So now we have one day. So please mute yourself. Any doubt you can raise. Okay. So this will so one day 1 lakh records, second day 2 lakhs records, okay, third day 3 lakhs records. So 1 lakh, 2 lakhs, 3 lakhs. It's going to the data going to increase. So it will take the time and we need to pay for that warehouse, okay, data loading process, okay, and the for storage cost, everything we need to pay, right? It will take time and we need to pay. So to avoid these, to handle these data, we have so incremental loading. So what is incremental loading? Okay, so first here, first day, what I'm going to do, I'm going to create three tables. One is from the source, okay, and source of minor table, and here I'm going to create again one stream table. Okay, one stream table, and one more table is like target 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 table. So the three tables I'm going to create using streams. Streams like CDC, change data capture, and we're going to have the task ones. First day I will load, okay, the source data I'm going to load into this one. The stream going to capture, CDC means change data capture. It's going to capture this data and it's going to load into this target lab. Here we go to the unique data. So again come to the second day. So here's some new data and duplicate data. So again we load it to source the stream going to capture, it's going to find out these are the duplicate data. So it will skip these files and it's going to load unique data into the target Ramayana. Okay. Again, third day. So what it's going to again we're going to load these data into the source Ramayana. Then it's going to stream going to capture this data. It will check for the so updates and it will check for the delete that last one record and you will check for the new record and it will load, it is going to update and delete that record and it's going to insert new data into the target Ramayana. So this is like incremental. So we're going to follow here in real time. Okay? We're going to follow here this structure. Okay, this is incremental process. So this is fine. Okay, from last 2 months, I think 3 4 months. So we are including the incremental. But so one new feature now. So the first process it will take the time truncate and recreate a truncate. Second is good fine. So from many variables using that streams on that logic only. And third one. So we have dynamic tapes. Dynamic
Hello.
tapes. Yeah.
Yeah, what is the truncate meaning? It will delete all records or it will, after deleting, it will keep in recycle bin.
No, no, no. Truncate means it's going to delete all records from the table.
Okay. After that, it will be not stored in recycle bin. It will enter delete the records.
Yeah, it going to delete the entire records. That will come in the subject. Yeah, we have the storage and micro partitions and time travel, right? So that is related to the. It means it going to inactive. Simply, it going to inactive. Those when we truncate, those records going to inactive. Okay. So whenever we need to record the data, right? So those records going to inactive. So after the data retention time in days, whenever it is expired, then it going to delete from the entire the database. Am I clear?
Okay.
Yeah. So your dynamic tables. So these are some advanced. Okay. So here directly it going to we can create one log diagram and we can connect with source and we can do the direct transformations. Same thing, but here same like it going to capture the data again like streams only, but this is not a CDC method. So if you want any output from the data, okay, any output we want to see directly when you are loading data into the source from directly SCD Snowflake, directly we can see the dot like total visits of doctor, those things we can see. So that is use of dynamic tables. And we have the so iceberg table. So if we load data into the Snowflake, we need to pay, right? Okay, you need to pay. But when we have we can create a like extend table and we can see the data, we can use the data. So that is for the iceberg tables. So that's those things I will show in the practical in the live. Okay, those things. So one more thing, then we have hybrid tables as iceberg tables and dynamic tables. Okay, and so many things we have. Okay. So this is and next come to and historical data. Historical how to handle. Suppose I have the bank account. So I know today what is my deposit amount or what is my withdrawal. And today I don't know. I know about compare my transactions. What is my balance? I know. So when you go to the bank, within a second you're going to get a message right to your mobile phone. Your like your balance. So like that. I know today, but I want to know about last 1 year transactions on every day. And I know I want from last 5 years. I know from last 10 years, I need to know. Okay. I need to know my transaction details. So when you go to the bank, so when you apply for the bank statement for last 10 years, so they're going to give you, right? So those data going to store in the Snowflake. We need to handle that data, historical data. Here we're going to use SCD type to access the historical data. Like we can slowly change your dimension. We have type 0 to type 6. Type 0 to type 6. Slowly change dimension. Here in real time, we're going to use SCD type 2 and SCD type 1. So both we're going to use. So remaining, we don't use that much. So most of the time, we're going to use SCD type 2 and SCD type 1. So this is okay. So we have some out of concept like from the Snowflake. We know so zero copy coding, time travel. So those are little things. Little means like we can learn easily, but out of concept. So what is a normalization? What is a OLTP overlap? What is a detailization? What is the schema modeling? Data warehouse, data lake, data may, data mart, okay, issue type and confirm dimension, concept dimension. Okay, what is ELT, ELT, ETL, and Informatica, and what are the cloud sources? What is the types of data and file formats? Okay, so why, what's Snowflake going to support file formats? So everything out of concept we're going to discuss as well as inside. Okay, here complete syllabus we're going to cover, and plus as well as so complete real-time work with a large data, not 10 records. We're going to take some like many tables, like 26 tables and healthcare data, and bank and retail. I will provide the data. So and again, so in each table we're going to have the columns like as per the requirement, 100 to 150 columns, and the records are going to be more than 2 lakhs records. So completely real time. So raw layer to curator layer and dev environment, test environment, and deployment environment. We have three environments in the Snowflake. Okay, every environment. How we going to move the code dev to test to production? Who is your team members, admin, architect, developer? So not only developing, after completing these courses, you can apply for the Snowflake architect, Snowflake admin. So the main thing Snowflake admin. So I'm going to cover everything and list also to these things. So here to see type 2 we have and then we have other things like metadata view and security metadata views and store procedures and UDF functions, UDF user defined functions, store procedures and giants, left giant, right giant, full giant, outer giant, and how to delete duplicate values. Okay, what are the SQL functions and what is pivot and unpivot, okay, and how to use the window functions, how to use the aggregate functions, okay, and what are the subqueries, what is CTA, okay, like, okay, then CTA like and the clone, what is the difference between these three things. So everything we're going to cover, so start to end, highly project level. So I'm the corporate mentor. So, so every month I'm going to place a minimum like from the colleges, or every month I'm going to be like 21 students. Okay. So last time I have done in this Malaredi college. Okay. So there are out of 40, there are 21 placed. So, and here from my side every day, every week, 3, 4 numbers going to place in every come like TCS, card, that IPM, so many things. So directly a simple thing you're going to get real time work, but you need to follow the my method. You need to follow the my instructions. So class will be at 8 a.m. So 8 a.m. Okay. We will discuss it next. Okay. So pivot and unpivot. Here we have the environment dev, test, and prod. So what we going to do? So dev we going to develop the code. Test we going to test with the real data, and production it going to directly to the production level. With these things, and we're going to connect with the GitHub. Okay, and so we're going to use a Jira tool for the ticketing and these things and those things, and we're going to follow the like Medallion architecture like bronze, silver, gold, yes, gold, these things. Okay, so you're and the AC type you're going to implement for historical data. So there is 1 minute. So rejoin with the same link now. We're going to discuss still. Okay, rejoin with the same link now. Just now. Okay, I'm going to enter the meeting. There is 1 minute. Rejoin with the same link.